Bienvenidos, Husham indeed, and welcome Anne Arundel Community College learners from CTS-130, Section 402, for the spring 2021 semester. This is the Cisco Networking Academy's Introduction to Networks version 7 course curriculum, or the ITNv7 course, and in this packet tracer activity, packet tracer 13.2.7, we're going to take a look at using ping and Traceroute in order to test network connectivity. Now, there is some troubleshooting that we are going to need to do here, and here's the topology that we are going to be working with. And you can see we've got some IPv4 addressing on the top of our diagram, and we've got IPv6 addressing on the bottom. And so what would you call that when routers 1, 2, and 3 are doing both IPv4 and IPv6? Exactly, we would call that dual stack routing because they're using both IP versions as part of the IP stack, version 4 and version 6. So we say it's dual stack. All right, so there's our addressing table. Let's drop down here and let's just jump right in. We've got the user exec password Cisco, privilege exec of pass. And the first thing we're going to do is test and restore connectivity. Again, there is troubleshooting that'll be involved here. So use the ipconfig and ping commands to verify connectivity. So let's open PC1 up here. Let's get to the command prompt and let's type in ipconfig-all. Now, this is asking us to complete and collect the information related to IPv4 and to fill that in the addressing table above. And so here's where we would see that information on the PC. So there's the PC's IPv4 address, 10.10.1.98. And as you can see up here, the subnet that we're working with is 10.10.196/27. And so to figure this out, it's rather simple. We know that the CIDR notation's a /27, meaning there are how many bits that remain for the host bits? There's 5. 2 to the 5 is 32. There's my block size. And so that means that if this network ID is .96 or 10.10.1.96, the next network ID would be what? It would be 128. And we can also confirm that when we see the broadcast address value, which should be .127. And so our usable IPs in this range are from .97 to .126. And so I'm going to just kind of mark this up here. So .97 to .126. Those are the usables in this network space. And again, I'm going to leave that up there because we'll refer to this later. So we've got 30 total usable IPs. Now, here is the subnet mask in dotted decimal notation, 224, which we know is a /27. And we're using 10.10.1.97 as the default gateway. And so we can quickly check that, right? I can try to ping 10.10.1.97. So can I ping my default gateway? I absolutely can. So we've got all the information in step 1B. We've got the IPv4 address, we've got the subnet mask, and we've got the default gateway. So now we're going to take a look at PC3. And again, the activity looks like it's going to have us start out here with the IPv4 information. So let's say ipconfig/all. And here we see that we've got the IP address 10.10.1.18. And so let's go ahead and I'll actually fill this in. I believe this was 98, so I'll just put a 98 here in the monitor. And so this is going to be 10.10.1.18. Looks like the default gateway is going to be the first address. And so the default gateway here was .97, so we'll draw that out for future reference. And so my guess is the default gateway will be the first assignable. And if we look right here, you can see that it is. It's 10.10.1.17, right? And this is a /28, meaning that we only have 4 host bits remaining after we've borrowed the network bits. And 2 to the 4 is 16. Take away 2, And we know that we've got 14 usable host IP addresses. Now, remember, my block size is 16. And if this is the network ID .16, the next network would be .32, meaning my usables here are going to be from .17 to .30, because 31 is going to be my broadcast address, right? 31 would be the broadcast address, just like the bcast right here. I should probably put bcast or just BC for broadcast address. All right. So now we've kind of got this network sorted out. And so if we were to document all the information, we can see here the IP address, the subnet mask, and dotted decimal notation, the default gateway. So can I ping my default gateway? Let's give it a try. 10.10.1.17. And we can, and everything works great there. So we would complete the addressing table with all that IPv4 information. Now we're going to use the ping command to test connectivity between PC1 and 3. So let's come over to PC1, and this is a common test that gets run when you're trying to test connectivity between two hosts. Ping 10.10.1.16. Now, take a look at what's happening here. The router 10.10.197 is responding back saying destination host unreachable. So now if I look at this, let's see what they're kind of recommending here. It says from PC1, enter the necessary command to trace the route to PC3. Now the traceroute command is simply going to give us an indication of each of the steps that this packet will travel from source to destination. So on Windows, we simply say traceRT 10.10.1.18. I'm sorry, did I ping 16? I pinged the network address. I apologize. I should have pinged 10.10.1.18. I looked up and I saw the 16. And again, we're going to get the same thing, right? Because we can't get there. But I apologize. It's 10.10.1.18. So then let's say traceRT 10.10.1.18. And let's see how far we can get. So we get to 10.10.197, and we know that that is router 1. That is our default gateway, but we don't get any further than that. And you can see that's the output that we're receiving back. Okay, so what is the last successful IPv4 address that was reached? And again, it would go for 30 iterations here if we continue to let this go. So it says from PC3, enter the necessary commands, and we can just simply do Control-C here. So we'll kill that. So let's jump onto PC3, and let's try to trace over to 10.10.1.98. And let's make sure we get the right IP address in here. And so you can see that PC3 is able to make it to its default router, but it can get no further. And so what we're seeing here is that both of these hosts, when they try to trace route to each other, kind of end up with the same result. They make it to the default gateway, but the default gateway can't make it any further. So from the default gateway, we can't make it any further. So we can also do Control-C to kill this as well. So now we're going to take a look and try to figure out what the problem is. So on router 1, let's jump into router 1 here, and let's pull this down and give ourselves a little bit more room with which to work. And so here we are on router 1. So it's going to be Cisco and then class, and that gets us into privilege exec mode. And let's go ahead and say show IP interface brief. And so we can see that the gig 01 interface is up. It does have the address that we believe to be the default gateway. Again, remember, we were pinging that address. And then the serial interface is 10.10.1.6. So what are we doing here? Okay, should have been recorded in step 2 on the router. We've got that. What is the other? So there is no other address. So we said show IP interface brief. There are 2 IPv4 addresses on the router, or should have been recorded in step 2A. What is the other? Oh, the other address that should have been recorded is the 10.10.1.6, and that is this transit segment here. And we call this a transit segment because it's simply between the 2 routers, and packets will be transiting these routers to get from one side of this network to the other. Here is the subnet, and it's a /30. Remember, in a /30, there are only 2 usable IPs. And so if router 1 is using .6 and the network starts at .4, we know the block size is 4. So the next network would be .8, meaning this network right here ends at .7 is the broadcast address. So my network ID is .4. My broadcast address is .7. My 2 usables are .5 and .6. And that's how if I see that the first one here is .6, I know that router 2 is going to be .5. So enter the show IP route command, right? Because now we're going to get down to brass tacks here. So show IP route. And when I say show IP route, take a look at the networks that I know about. So I know about the 2 networks and only the 2 networks to which I am directly connected. Now, remember, this is from an IPv4 perspective, because you might be looking up here and saying, well, hey, this network doesn't show up here to this IPv6. Remember, I'm saying show IP route. That implies IPv4, right? So we're not going to be seeing IPv6 information just yet. So the only 2 networks router 1 knows about are the networks to which it is directly connected. In other words, it knows about the /30, and we see that right down here in the serial 001 interface. And then it knows about this 10.10.1.96 because, again, it's directly connected to it. So the problem is that when PC1 tries to ping the 10.10.116/28, or an address in that range, I should say, that router 1 gets the packet and says, okay, the destination IP field, or the destination IP field in the IPv4 header is telling me to go to 10.10.118. I don't have a network that covers the 10.10.118. Therefore, I'm going to respond back to you, PC1, and tell you destination 10.10.118, destination host unreachable. This is router 1's way of telling PC1, hey, I got your packet, but dude, I don't know how to get there. I'm sorry. I have no route. I can't get you to that destination. So that's what I'm going to reply back to you with for further investigation. And so we get on to router 1, and we can see that, yeah, router 1 has no route to the 10.10.116/28. Now, there's a number of ways that we can fix this. Let's make sure that we're following along here correctly. And enter the show IP route command to list the networks to which the router is connected. Note that there are 2 networks connected to the serial 001 interface. And the 2 networks are the directly connected and then the local entry, that my IP address on my interface. Those are the 2 entries that you see there. So repeat steps 2E through G with router 3 and record your answers. So we come on to router 3, and my guess is that we're going to see much the same thing here in terms of Cisco and then class, show IP interface brief. Again, IPv4, right? So what do we see? Well, we see the network to which it's directly connected out the gig 01 interface to switch 3. And that makes sense. We can ping that. We see the interface is up. And then we see the serial 001 interface for the 10.10.110. Again, it's going to be the transit link IP address on router 3 on this serial 001 interface. But now let's say show IP route. And my guess is that we see again these 2 local entries here. And then we see the 2 local entries for the LAN segment. But we don't see a network entry for the 10.10.196/27 network, which explains why when PC3 tries to ping router 3, router 3 politely says, I'm really sorry, but that destination is unreachable. That host is unreachable. I can't get you there. I'm really sorry, right? And that's what's happening here with these replies that are coming back from router 3. So let's click on router 2 and get logged into router 2. And let's see what's going on here with router 2. And again, there's going to be multiple ways that we can fix this. And it looks like they're running EIGRP here, which I think is interesting because it's not even covered in the CCNA anymore. And maybe OSPF would be a better choice because that is covered in the ENSA version 7 course. But again, let's go ahead and say show IP interface brief. And then we can take a look at the two serial interfaces here, both for serial 000 and 001. And we see that we've got these two IP addresses. Again, remember, router 2 is simply between these two other routers. And so router 2 is doing nothing but allowing packets to transit, right? It's not connected to any LAN segments. So run more tests if help is needed to visualize the problem. Simulation modes available. So propose a solution. So compare your answers in step 2 to the documentation you have available for the network. What is the error, right? So the documentation we have available is going to be all of this information that we have here. And we know the problem. The problem is that router 1 doesn't have a network statement or a route to the network for PC3. And router 3 doesn't have a route to get to the network for PC1. And that is our problem. So there's multiple solutions that we could propose here. If these routers are running EIGRP, we could originate, which means advertise, make known this subnet into EIGRP. And if we come onto router 1, and again, this isn't an EIGRP activity, so I could say show IP route EIGRP. And we don't see, remember, we don't see any EIGRP information. In fact, let's even see show run section router EIGRP. So we are running, or we have the routing statements in here for EIGRP, and we even have the correct network statement in here. So it looks like if I say show IP EIGRP, neighbor, we have no neighbor. So it looks like EIGRP is not working. So we could fix EIGRP. That's one possibility. Another possibility is I could put a default route on router 1, basically saying if you don't know where to go with the traffic, just send it out the serial interface. And then on router 2, I could do two static routes, one that points to this network here, and one that points to this network here, out the respective interfaces, and then put a default route on router 3 that says send all traffic to router 2 if you don't know where to go. And so you could do that. So we could either fix EIGRP, or we could go ahead and put in some static routes. And so the question now becomes, and it says step 2 in the documentation, which was all of this information here. So I'm pretty sure they're not going to want us to fix EIGRP. That's not something we've even covered. So what we could do is we could do static routes for each of these networks, or we could do a default route. So let's see what it is that they might be looking for here. So let me get into global config, and I'm going to say my route to get to, and actually let me take a look at router 2 real briefly here. Hold on one second. Let's say show run include route. Let's see if, yeah, show run section router EIGRP, show IP EIGRP neighbors. Okay, so 10.1. So it does have a neighbor relationship with router 3, but not with router 1. So something is wrong between router 1 and router 2's EIGRP config. As you can see here, this show, and again, this isn't an EIGRP activity, and this can't possibly be what they're looking for. So there are no static routes here. Excuse me. So yeah, let's go ahead and do this. So I'm going to basically, let's see if it wants a default static route out that serial interface, serial 001. So I'm just creating a default static route, and that is not what it was looking for. So we're going to pull that out right away. And we're going to say my route to get over to the 10.10.1.16, and this is not a wildcard mask here. This is the dotted decimal subnet mask, is going to be out serial 001. And it looks like that is also not what they are looking for. And let me see if they want not the outgoing interface, but if they want the next hop IP. So let me pull back this statement here and see if they want me to put in here 10.10.1.5, which is going to be router 1, and that's not it. So let's pull this back. And let's say no, and then we'll pull back the very first quad statement and see if they want us to go to 10.10.1.5. And again, oh, sorry, I said no IP route. Thought I might have mistyped the IP address there. Let's come back here and let's pull this. And that is also not what they are looking for. So let me take a quick peek here. Oh, and this is one of the activities where we can't pull up the answers, which is why I was getting so many emails asking me when this video is going to be posted. All right. So again, it can't possibly be that they want you to fix the IPv4, or I'm sorry, the EIGRP, but I guess let's take a look at that and see. Do show run. Let's see. The IP address here should be .6 on that serial interface, and it is. There's the link local address. That's a /30, and the IPv6 for EIGRP information is in there. And let's take a look at the EIGRP config. 10.10.1.4. That is correct. 10.10.196.31. That is correct because it's a 224. And so that EIGRP information should be correct. Let me see the IP address here on router 2. Let's see, show IP interface brief, and it should be .5. Aha, okay. So I see the problem that they wanted us to find is that depending on, let's get into global config, and I could actually mouse over it and we'll see it. So I think we see the issue here. Again, my apologies. This was me not understanding, and obviously you can tell I haven't looked at the answers. So this is me trying to figure out what it is they're trying to ask us to troubleshoot, when in fact it's right there on router 2. So the serial 000 interface, that IP address 10.10.1.2 is not in that 10.10.1.4/30 network. That's why the EIGRP adjacency isn't up, and that's why we can't get beyond serial 001 on router 1. So we're going to go into int serial 000. We're going to say IP address 10.10, and I had actually stated about 5 times that the IP address here would be .5, and then we took a look at router 2, and I just kind of glazed over it. So that's what the IP address should be, and you can see it brings up EIGRP because now we have the correct IP address on this interface, and the activity has bumped to 60%. So now that we know what they're looking for, now let's verify connectivity again. So here on router 1, if I was to say show IP route, you'll notice that we're now receiving a static route, a static default. That's what that S asterisk means, right? The asterisk is a candidate default. Excuse me. And so now we have the default. So the static default we could have done, but then we would have had to have done some other work with default routes, but that's not what they were looking for. So let's now go ahead and try to ping 10.10.1.18 PC3 and take a look at that. We've got connectivity. And now let's go ahead and let's do a trace route over to the 10.10.1.18, and we should see each of the hops along the way. The 97 being the default gateway, the 5 being that IP address we needed to put on the router, the 1.10 being the IP address on router 3, and then 18 being our destination. And so we're done with the IPv4 information. Is the problem solved? It is. So document the solution. We had the wrong IP address on the serial 000 interface. on router 2. So now that we know what it is we're kind of looking for here, let's dive in and take a look a little closer at the IPv6 configuration. So on PC2 down here, let's go ahead and say, and again, on a real Windows box, you would just say ipconfig/all. Here in Packet Tracer, they're asking us for IPv6 config-all. And this is where we see the IPv6 route addressing information. Again, there's our link local auto-magically EUI64 generated address, and here is the global unicast address. There's my default gateway, which I'm learning from those router solicitation and router advertisements that are going out. And that tells me that the link local address on the router interface here to PC2's LAN segment is FE80::1. In fact, let's ping FE80::1. And we've got connectivity there. So we see all the address and information. I can ping the default gateway, click on PC4, and we've got PC4 open already. And let's say IPv6 config/all. And there's all that information. Can I ping FE80::2? And let's see if we can ping FE80::2, which is listed as my default gateway. And I cannot ping FE80::2. Again, usually the first step, I like to use sort of the follow the path, right? Troubleshooting method. So the first step is, can I ping my default gateway? If I can't get to my default gateway, then the problem is probably local to the segment to which I'm connected. So test connectivity between PC2 and PC4. The ping should fail. It most definitely will. And what is the global unicast here? So 14::2. So I would say ping 2001:db8:, and I'm going to have to go back here. Is it ACAD? No. Okay, so it's 14, so :1:4:2. And we know that this is going to fail, excuse me, because PC4 can't even get back to its default gateway. So locate the source of the connectivity failure. From PC2, enter the necessary command to trace to PC4. So on PC2, I'm going to try to trace over there. So let's go ahead and say traceroute to, and let me do this. I'll pull the address up, that way we save time typing the address. So the traceroute, so I'm making some progress here. And you'll notice I can get all the way over to the 2001:db8:1:3::2. Right? Well, here is that /64 network. So if I pull router 2 up, let me go ahead and say, show IPv6 interface brief. And does that :1:2 reside here? It doesn't. But I'll bet you it's that serial interface right here on router 3. So let's pull this back up. Let's say Cisco, and then go into privilege exec and use the password class, show IPv6 interface brief. And there is that address. 2001:db8:1:3::2. And that is as far as I can get, is router 3. So PC4 can't ping the default gateway router 3, and PC2 can get to router 3, telling us that the problem might be somewhere on router 3. But let's see what's going to happen here. And they want us to do the trace here over to, and let's see if we pinged, did we ping that address? We pinged the default gateway. So I'll say traceRT 2001:db8:, and let's quickly look back over here and see what is our 112. All right, so :1:1:1:2. And how far can we get? Again, if I can't ping the default gateway, it's highly unlikely I'm going to get beyond the default gateway. And you can see here that I can't. So they're kind of guiding us here. It says click on router 3 and press enter to log into the router. And they want us to run the show IPv6 interface brief. And what is it that we notice here with the link local addresses? The default gateway on PC4 is set to FE80, and I think we're still running something down here. There we go. It's set to FE80::2. If I mouse over, the diagram here, you can see that the interface is gig 00. That's going to be my default gateway interface is gig 00. So you can see here that it doesn't show me the link local addressing when I mouse over the router, but if I click on the router, we see the link local addressing here. What's the problem? Yeah, it's that PC4 has an incorrect link local address pointing to router 3. It's pointing at FE80::2. That's got to be the link local on router 2 probably, but it's wrong here on PC4. The solution that I would propose is that we come in here and let's see, it couldn't have gotten that. Yeah, it couldn't have gotten that from DHCP, right? And you can see we've got a static configuration here. So someone just typoed that, and so we're going to put in the 3. I'm going to click out of that box. The packet tracer activity goes to 100. And we pull this back up, and now let's see, can I trace over to PC2, and can I ping FE80::2, which is my default gateway. I'm sorry, ::3 is what we're trying to ping. I can't ping FE80::2. Again, that's a fortuitous failure, proving that it's a link local address. Even though it exists on router 2's interfaces, I can't get there because I'm not connected directly to router 2 on a local link. So I can get to FE80::3. In fact, can I ping over to the same address I trace routed to earlier? And if I can trace route there, there's a very good possibility that the ping is going to work because we don't have any ACLs that are set up, access control lists that we can use to block traffic. All right, so everything works. Now you would document all the information here, IPv4 and IPv6 information alike, to go ahead and complete that addressing table so that you know exactly what this network is going to look like. So as a recap, the two issues: wrong IP address on router 2's serial 000 interface, and wrong default gateway, IPv6 default gateway on PC4. And my apologies at the start of the activity for trying to figure out what it was they were asking us to find. All right, well, that is going to do it for Packet Tracer Activity 13.2.7. If you guys have any questions, please be sure to contact me. And that's it. Thank you so much for watching. And as always, I hope to see you in the next video.